okay, we're going to be looking at limits, whether they exist and when they don't exist. So a limit will exist if and only if you take the limit of a function as x approaches a certain value c, and it's headed towards an actual number, real value, so we call that the limit or the height. Remember, as it's headed towards not an asymptote, but towards a number, then that limit exists. The other rule is that if you're looking at a function, let's say I'm going to say that I want you to look at that point right there. If you look from the left and from the right at a given c value, so let's put c right there. As we come from the left, it goes to that height, and as it comes from the right, so if the limit as x approaches c from the left side is as a certain height, and the limit as x approaches c from the right side is the same limit, then we know a limit exists. So the big thing to remember is the left and the right side of a graph, they need to agree for a limit to exist. When do limits not exist? All right, so if you have, we're going to be looking at piecewise functions, piecewise, and special types of absolute value functions to be looking at when limits don't exist. So this piecewise function right here, piecewise means if you've got a function, f of x, and it's broken down into two places, so maybe here's C, part of the graph is going this way, and maybe part of the graph is going that way. It's still part of one function, it's just broken down into different pieces. Okay, so when you have a piecewise, and you substitute the c, so g of c and h of c, if those two values disagree, if those heights are different, so one of the graph looks like this and one of the graph looks like this, and you see there's a big gap, whoops, the left and the right don't agree with each other, that's what's happening right there, then all you have to say, the limit as x approaches c, and because there are two parts of this function, you're just going to write f of x because it has two pieces, and then you're going to write does not exist. That's all you have to do. You have to check, you have to plug the c value into each function. If the heights are different, then the limit doesn't exist. If they're the same, then you just, let's say a and b were the same height, so we're just going to call it a, then you just put whatever that a value is. And we'll be practicing these in case that was just a little confusing. And then the second one we're going to look at is absolute value. So the special absolute value ones that we're going to be looking at is when it's a rational expression, a numerator over denominator, and one part, either the numerator or the denominator, has absolute value bars. This is what that graph looks like. And this, you may just need to memorize this so you don't have to do a table every time. So if we say this is the c value right here, so c, positive c, is what will zero out the numerator and the denominator. Whenever zero's in the denominator, it's not going to work, right? It's undefined. So this is what a rational absolute value graph looks like. And if you notice, as you read from left to right, as you're coming from the left side, as you're coming from the right side, those two heights disagree, does not exist. Now, when we start doing one-sided, and all we have to look at is one side of the graph, well, then we do have a height. Same with over here. If all we're going to do when we look at one-sided is maybe we just want to look on the right side of C, well, there are heights over here. But when we're not looking at one-sided, when we're just looking at piecewise and we're looking at absolute value, and on the left and on the right, those heights do not agree, you just write D, capital N, capital E, does not exist. Okay, the next few videos will cover the one-side limits of piecewise and one-side limits of absolute value. All right, that's it.